what I'm going to share with you a little bit is about what we are doing in big data and share with you how we look at big data and what are we seeing in the activity level. We have been doing several prototypes and have built a couple of projects. A lot of this talks about how we see big data being used by customers, more than just about how big data solutions are being built. All right, so big data is happening now. There are, there's a lot being written about it. There's no week where you can't find enough articles on big data. And clearly, what we find, and I'm going to share with you some of the changes that we see here. The way databases have looked at data in the past is definitely changing, and people are looking at data in very different ways. And we see that in the market. Okay, so before I get further, I wanted to share with you a little bit of a slide where we see that the enterprise value is shifting to data. So if you looked at in the past, sort of mainframes were the main driver for decision making for the CIO. So somebody decided the mainframe and then everything else followed on top of that. Later on it became the operating system, so people decided they wanted to go with Unix or Windows, and then what hardware, what software they were putting was a function after that. Then it became the database, so people decided they wanted to put an Oracle or an Informix, and then decisions on top were determined by that. Then it was the ERP. Then we see already the apps. And I think the next thing after that is going to be data. So people are going to look at data as the place to go and then use everything else to become a commodity. So when you have a situation like this, all the layers below are going into the cloud, and you get this line of diminishing value. So everything that is below these lines sort of becomes a commodity, and money is to be made on top of it. So we're starting to see already people are willing to trade off apps and give them away for free to help you use their data and to collect the data, so that you can see how the data can be leveraged for various other exploits. So this is something that we are seeing everywhere, and data and aggregation of data in the cloud is where we see a lot of activity, and this leads to this whole thing about where big data is getting used. So organizational leaders want analytics, and yes, this has been done predominantly in the internet space, but with the way the data is moving on, this whole combination of internet technologies being used in the enterprise for big data is what I'm going to talk about mostly. So here's an example. This is an example from Tesco, where Tesco has been looking at weather maps and weather predictions to decide what kind of goods to shop in their stores. And again, this is very relevant in UK, where weather is always a very unpredictable item. And they have seen significant difference in their returns or what inventory gets bought depending on the weather patterns. So tracking weather, which is an external factor in addition to their internal transaction system, is where the interesting excitement is these days. Similarly, this is from social media sites, and this is from GSK, where they are trying to look at social media activities and look at what people are doing on Twitter and various other feeds to see what products are being bought and what exactly is happening. So this is already happening in mainstream engineering companies. We have a product actually activity going on in India around one of the most popular shows in India called Satyamev Jayate. So this is a show led by Amir Khan, who is one of the best known Bollywood actors. And he is doing a social show every Sunday morning at 11 o'clock. And he does this on television, where he's picking up social issues like female feticide, malpractices in medical treatments, and social issues like that. And beyond that, there is a whole lot of Twitter activity, Twitter, Facebook, and a whole bunch of social activity that is coming back out of that. And as Persistent, we have been tracking this for Amir Khan Productions to try to come up with analytics on what people are thinking about in the context of some of these social issues. So we are seeing a lot of examples of big data and data of all kinds being leveraged. Now, so I'm going to skip this. So we already have databases, and everyone has used databases before. So what's different, and what are we doing? What's the big deal here? So this is sort of what I want to share here. Okay, so relational databases have been used for since last 30, 40 years now, and they are all over the place. It's more than 100 billion-dollar industry already. And this is what I refer to as DataStack 1.0. It's being used for standard transactions. In the warehouse is the other data store that people have in the organization, which is where people take all the data from operational stores, stick it into a common warehouse, and then do analytics against that. Let's refer to this as the DataStack 2.0. And overall, there is, if you look at the architecture, you have DataStack 1.0 and DataStack 2.0, and this is pretty standard in terms of the architecture. Despite these two data stacks, okay, and this is from one of the IBM Institute reports, most CIOs and CEOs will tell you that despite having these data stacks, they still don't have the right data for making their decisions. And many of the decisions are being based on things that are beyond what is there in a data warehouse. And the reason this is happening is because data has, today in an enterprise, the data that is stored in an operational store, which is then warehoused, is only one kind of data. Today you are looking at, as I gave you the example on Tesco, where people are looking at weather maps and weather data, there is a whole bunch of data which is completely different from what may be stored in data store, stack 1.0 or 2.0. And this is all, it's observed that more than 70% of the data that is useful to the enterprise will never really hit the warehouse. And I may be quite generous when I say 70, maybe even beyond that. And especially when you look at data beyond the operational store, and we are starting to see many of this, like for example, email systems, workflows, document repositories, then stuff on the cloud, and also beyond that in public data sources. All of this data is being used by organizations to make decisions, but a lot of this data is never really going to get into the warehouse. And this is something that we have observed as well. Internally, we'll show you a demo on some of the stuff we have been doing with respect to email systems, where we have been doing email analytics against our own email, and we were able to get some pretty interesting solutions from there. Like one example I want to share with you is that we had this activity internally to try to find out how much time do managers spend on non-productive activities. Okay, now it's a good question to ask. And this is something that we keep asking ourselves to try to push it. And we found that we did several things like conducting surveys and all of those things. And people don't give correct results because they tell you on surveys dates which they want you to know, but they always say they're spending too much time on it, but it's not clear. So then we have an analytics solution that we may be able to show you today, where we were actually able to look at all the emails being spent by people, and we find that anything that is non-productive, like you want a request for resources, travel, whatever, it's all initiated through an email and responses through email. So by looking at email and tracking analytics on that, we were able to get a fairly accurate estimate of what project actually spends too much time in doing these things as against some other projects not doing it. So the integration of email data along with the organizational hierarchy and other data that was already in the ERP system was able to give us some very detailed information on which projects and what exact activities, why are certain projects spending too much time on requesting IT support or things like that. These are questions we could not have answered any other way. Employee surveys and various other things, again, we find there is a lot of opportunity in looking at data that is beyond what is stored in a typical data warehouse. Again, data volumes are growing dramatically, and this is a quote from Eric Schmidt, which is kind of fascinating in some sense that we are creating so much data. There is a similar slide here which says that we are going to see 44 times as much data as we have today. And these numbers, again, are anybody's guess, especially if you look at all the stuff you can look at with respect to social analytics and other data sets. Okay, this is again another interesting challenge that we see here in terms of when you look at existing data sets such as DataStack 1.0 and DataStack 2.0, they tend to be very structure first. It's always a chicken and egg. I have all this data. If I can figure out what the structure of that data is, then potentially I could load it into my warehouse. So this whole schema first business kind of slows down your ability to take data from all kinds of different sources. And even if you knew how to do it, the ETL processing that is required in just trying to clean up the data that you have forces you to look at it in a particular way. So one of the challenges that you have is that we find that when you look at these kinds of queries, like looking at weather or email or many of these kinds of things, you don't know a priori what kind of things you're going to look at. So you want a way of keeping the data in some place where it can be stored in large quantities without having to worry about the specific details of the format and other things. And then you can run batch processes or other activities to invent or discover new things. And as you get new stuff, then you can figure out how to put it back into your warehouse and then do meaningful queries with it. So a combination of these things is where you're looking at. And this takes us to the need for creating a new data stack for unstructured data, which I refer to as the DataStack 3.0. Okay, so the DataStack 1.0, as I mentioned to you, is your operational data store. We've used it for many years. DataStack 2.0 is the enterprise warehouse. We think that beyond that, there is a need for a DataStack 3.0, which will store petabytes of data in large volumes, which has a more of a schema-less approach. And combination of DataStack 1.0, 2.0, and 3.0 are required within the enterprise to be in a position to do analytics against these new data sets. Okay. Now, one of the other questions to ask is that, when you have a situation like this where you're going to create a new data stack, clearly you got to do something more than just what is being done by 1 and 2. So one of the things that we've been looking at, and this is partly a lot of experimentation going on, is to say that is the unstructuredness of the data that important for some of these DataStack 3.0 queries, or are there inherently certain queries that you cannot answer today using the relational database at a cost-effective and a time-effective manner that you could do better because you had a different set of algorithms that you are using from Hadoop and various other areas. So we have been trying out several examples where is it possible to store large data at low cost, and how does that happen using these new techniques? Is there diverse data beyond structured data? How do you store it? And are there queries that are very difficult to answer in the current relational warehouse situation that you can answer better using these newer techniques? And we have actually an example of something we have been working with that I will show you towards the end, where it's a fairly structured standard relational database data that we are looking at. And we have been running just different sets of algorithms on top of it. And we are able to get results that were not possible to compute on the current relational systems. So there is a combination of things for which these kinds of systems may give you better results even if the data is structured. And again, sometimes these kinds of queries are just too overbearing. The time it takes to get an answer may be so long in terms of the effort that is required to get the team geared up for writing the ETL and doing all this stuff that people don't ask many questions about their data. So potentially what we have seen is that when you're looking at these kinds of new data stack algorithms, all of a sudden people are asking questions that they would have never asked before. And that in itself is a good thing. And I just wanted to share what we have seen is in the last about 4 months or so, we've been doing 2 or 3 prototypes or POCs every week with some customer or the other about different things that people are asking us to demonstrate using a POC, saying, hey, can you show us that this can be done using the big data stack? And we have done several of these in the last, say, 4 or 5 months with one of our big partners, and some of the stories that I'm going to share are from those POCs. And what we also find from these POCs, and where I wanted to share that the importance of DataStack 3.0 is that, see, the market today is looking at big data as a point solution. So they go to it and say, can you solve this particular problem for me? And yeah, fine, we can show a POC and it works. The point is, am I going to invest a whole hardware stack entirely just for solving that one problem? And that's sort of where people get stuck. So one of the things that we find is that it is important that you build an ongoing architecture of DataStack 3.0 where you have a way of creating a new way of keep collecting your data and then incrementally keep finding new stuff from it. And then you can, if you can amortize the cost of building your data stack over multiple applications rather than just one, then you will find that this all works out very well. So I want to share with you from here on a little bit about what we have been building. So what has happened in the last few years is that many of the internet companies have gone ahead and built this kind of infrastructure anyway. In the last few years, 2 years or so, we are starting to see this becoming open source available. And many companies have come up with business models to support these products, including the largest ones like IBM, Microsoft, Oracle, EMC. And all of this is now starting to go into the enterprise. And one of the things that we at Persistent have been doing is, for the last many years, we've been working with companies in this space, in the internet space, helping them build these kinds of Hadoop-based architectures or NoSQL engines as part of the product engineering business that we do. Over the last 6 months or to a year, we have built a layer on top of this whole infrastructure, which I want to share with you, which allows us to go to customers and build out these prototypes and POCs very efficiently. And this is what we wanted to show you. Okay, so the point here is that enterprises always have had data. Now there is a new way of looking at it. And we are able to look at unstructured data in large numbers. Yeah, so as I mentioned, Persistent has been working with many of the companies from the sort of the Yahoos and others who have built out this infrastructure for many years. So the Hadoop infrastructure is something that we have implemented for companies that have been in the internet space for a while. Now we find that this architecture and data systems that have been built out, now open source and also now robustized by companies, are very valuable to enterprises, and that's sort of where we have been working with companies. So, we have had actually several products here that I have listed for whom we have worked with as an engineering team for building out their products. This has been going on for the last 3 to 4 years. Let me move to the next one. We have been contributing code into some of these libraries. So we have stuff that has gone into Hive. For example, there is a query rewrite piece for Hive that is being checked into the source code system, where we take the queries that come out of Hive and they are significantly improved. We have an indexing system that has gone into Hive that has been built by our team. And on Hadoop as well, we have several contributions that have gotten checked into the main code base. So we've been working on the sort of the techie side of this business. And what I want to share with you is some of the new stuff that we are doing in the context of the end users. So clearly there is a foundation platform. So here's what we have been implementing now. So of course there is a foundation layer that is available in the market. You can download it, but it's also available from IBM and Microsoft, and everyone else has a Hadoop layer that is pretty much common and available. What we have built on top of this is we have built a library which we call Pebble. Here what we have taken is, we have taken some standard class of algorithms such as graph algorithms, set algorithms, statistical algorithms, and some shortest path, shortest link analysis, text mining, and a bunch of different things. And we have implemented about 45 to 50 algorithms on top using this Persistent library that we have, which allows us to put together a Hadoop-based application very efficiently. This takes us into these pre-built horizontal situations such as email, text analytics, IT analytics that we are demonstrating here today. And of course, all of this stuff is, as I mentioned, we are doing many POCs. And the team required for getting this kind of job done is not available. So we have invested in training a large number of people, meaning several hundred people who are very comfortable with this environment and are ready to implement big data-based solutions for customers. So this is the architecture that we have. So we have first implemented a very large set of connector library where we have taken data from email, web proxies, various kinds of log files, Tivoli, logs, Twitter feeds, Facebook feeds, all of those kinds of things. And then the architecture that we have looks like this. So there is the Hadoop layer on top. On the bottom, we have Pig and Jackal, which is IBM's version of Pig. There's a text analytics engine where we are using System T. And then there is Hive. And on top of that, we have this thing called graph, set, text analytics functions. That's the Pebble library that we have implemented. And then what we find is that depending on the data set, our objective is to extract data from different wide sources, stick it into a Hadoop engine, which is capable of storing large volumes of data at a lower cost. And then you run different algorithms on the same data set that you have cleaned and pushed into the Hadoop tables, which we are using an HDFS and an HBase layer on top of that. And then we feed this either into a warehouse that you may already have, or a NoSQL database, or feed it back into a BI or analytics tools that you might need for getting various results that you want. So this is something that we have ready, and this is what we have been using to work with some of these POCs that we have been getting. So over the years, as we are building, or rather, not years really, over the last few months that we have been building this out, we have been collecting new algorithms to incorporate as part of the library. So this is essentially what we have been implementing. And these are in various categories. So we have sets, we find that there are a lot of queries which are related to graph theory or link analysis queries that we find are very efficient to do in using a Hadoop engine that are pretty hard to do on a relational system. So several other queries that we have gotten from customers who have structured data, trying to find links, graphs, top 10, shortest path, find all nearest neighbors. Those kinds of queries are typically very nice to do on an architecture like this as compared to doing them on a standard relational system in terms of what can be done. And then, of course, inverted lists, text mining algorithms, web analytics, statistical functions, and things like that. Just to make it easier, we have built a visual language that is like a graphical UI tool using ETL that generates pig and pig Latin, then makes it much easier to write pig, because while it's easy to say that you can write pig queries, it's kind of a pain to write them. Okay, this is again a very important aspect of this, because a lot of times you have data that is all over the place from different sources, and you need to get it into one unified place. So we have built several connectors, and this is something that we have done in the past as Persistent. So we have taken all those connectors and kind of Hadoopified them so that they can store data from different sources into a Hadoop-based infrastructure. And we have been able to do this quite quickly, so we are able to get new connectors to happen very efficiently. So this is the last about persistent capabilities slide. So we have a distributed file system, which is pretty standard. On top of it, the two layers on top are the layers that we have been building our own IP, and we've been trying to work with customers on trying to build more and more of these libraries that are pre-packaged and made available, and we've been doing several demos for customers. Let me just go to a few examples. Let's go to the next one. So here's an example I wanted to share with you. This is a fairly large airline customer that we've been working with. So they wanted to understand how to build a social graph of the people who travel. So if two of us travel to the same cities all the time, we end up at the same destinations, we stay in similar hotels all the time, then we can cross-sell to each other and do promotions through them. So they are very interested in finding out, do people have patterns? Do people move together, travel together, stay together? And how do you look at this from standard data that they have about their the flight tickets and also the hotel bookings? So it's again structured data, very large amounts of data, more than 1 billion transactions that they have collected over the last 20 years. And they want to find out those thousands of influential customers that they have in the database. Now, they have tried this using standard relational techniques, but these kinds of queries just take forever. But in a short period of a few weeks, we were able to demonstrate to them using Hadoop-based infrastructure fairly good results that are quite promising. Again, we'll show you a demo of email analytics. We found there is a lot of information that people are sharing through emails, and then the ability to mine sentiments of what is happening on what project groups, how do people know each other, an internal network of who knows whom. All of those kinds of studies that we have done using email analytics are something we are demonstrating here today. And we find that there is a lot of information in email, whether it's support calls, customer complaints, or whatever else. They're all coming in through email. And email, there's no nice way to look at email today, and this is really useful. And this is another interesting example that we have been working with a company that actually provides homes for the elderly. And what they have is they have a fairly large elderly home that they provide, and they're looking at prescriptions for the elderly, where they look at all these prescriptions to try to find out if they are not prescribing something that they should not prescribe. So again, large amounts of prescriptions, trying to analyze these prescriptions to find out if there are any violations in medicines that need to be given. So if someone is taking a certain medicine, then they should not be taking some other medicine and things like that. So again, this is a large database that we have looked at, synonyms, removing mistakes, erroneous prescriptions. Again, at large scale, this was an example we did for a company that was quite effective. Okay, last one I want to share with you about this Satyamev Jayate again. So this is where we are looking at data that is coming in from various blog sites, Twitter feeds, Facebook, newspaper articles, and looking at trends across weeks. So what he has been doing is every week there's a show on Sunday. And so for example, there was some legislation that he wanted from various states in India. So he did a show, and then all of a sudden lots of people write to him about, you should do this, you should not do this, and try to fix all that. And there's been a lot of analytics that we have been doing where we have been looking at video, audio, and text and tagging it so that we can figure out what people are saying when they are sharing personal stories, what kind of stories are important, and how do you take all this information and then provide it back to the producers of the show so that you can really make a difference. And it's quite amazing the amount of information that people are sharing in terms of specific cases where medical malpractices, they found personal cases or whatever else. And the ability to take this curated information back to politicians is something that has been quite amazing. And this level of interaction across the entire country in some sense has never been seen before. But now with this show and the analytics that goes after it, we've been able to get some pretty interesting data about what cities, what happens, and all of those kinds of things. So this is pretty much it in terms of what I wanted to share with you about what we are doing in big data and analytics. Clearly, these are still early years in the context of where this is going to go as a technology for enterprises, for mainstream use. But we have seen many customers where there are cases which are very effective. And we'd be happy to engage a conversation with any of you in case you see an opportunity or a problem where you think there may be some interesting case study that we could try out, and if you think it makes sense, then we can of course implement it later.